Hello and welcome to another video. My name is Parth. Here we are in the Grokking the Coding Interview series where we previously went through the merge intervals pattern, and in this video we'll start the sliding window pattern. If you have not gone through the merge intervals, I'll strongly advise you to first go through that pattern, build an intuition around it, have a look at some implementations, and then jump into the sliding window. We'll be covering all the patterns which are in this course. At the same time, what I'm thinking about doing or starting to do from the following videos is I've created or indexed the most important information from all these courses for each of the pattern, and it's openly available for you to use if you are going through the same process as well. So let's jump right into the sliding window pattern, try to build an intuition around what this pattern involves, and then we'll have a look at some of the problems. So in many problems dealing with an array, we are asked to find or calculate something among all the subarrays of a given size. For example, take a look at the following example. Given an array, find the average of all subarrays of k contiguous elements. So for example, what we have is here, let's understand this problem with a real input. We have this array as an input. We have a value of k, which is 5, and we are asked to find the average of all subarray of 5 contiguous elements in the given array. So essentially what you want to do at this point is you want to take every subset of 5 elements, for example, and calculate their sum, like average actually. So sum divided by the number of elements, which is k. So here we have a final array containing the average of all such combinations. A brute force algorithm will calculate the sum of every 5 elements subarray of the given array and divide them by 5 to find the average. And here is an implementation of such an algorithm. So essentially what we are doing is we are going through, from 0 until the len of array minus k plus 1. So essentially we are allowing a k length window at the end of the iteration for j in range I to I plus k. Okay, so this actually defines the window which we are looking at, and then we just calculate the array and we append it. So I mean, it is a brute force algorithm. We are going through all the subset of k elements and calculating the average. If we look at the time complexity of the implementation, we can see that since for every element of the input array we are calculating the sum of its next k elements, the time complexity of the above algorithm will be O n times k, where n is the number of element in the input array. So I mean, here at this point we have to think like, can we find a better, more optimal solution? Though you see any inefficiency in the other approach, the inefficiency is that for any 2 consecutive subarrays of size 5, the overlapping part will be evaluated twice. So essentially what they are trying to say is, if we first calculate an average of this subarray, and then we move on to calculating an average of this subarray, this subarray is essentially an overlap between the 2 calculations, and we aren't using this anywhere in how we are approaching the problem. Take the above mentioned input. So yeah, they're trying to prove that point again, which I just mentioned above. 4 overlapping elements between this and this. The efficient way to solve the problem would be to visualize each subarray as a sliding window of 5 elements. This means that we will slide the window by one element when we move on to the next subarray. To reuse the sum from previous subarray, we will subtract the element going out of the window and add the element now being included in the sliding window. This will save us from going through the whole subarray. So you do have a running calculation here, and instead of doing this calculation again on, say, the next 5 elements, you simply subtract or remove the element which moves out of this window and add the element which moves into this window. So you are efficiently avoiding having to do these calculations again. Okay, so in this case, we look at the more efficient implementation of trying to calculate the average of all such pairs. So here we have a window sum, we have a window start, and we have a window end, where we simply iterate. So window end will take from 0 until the end. So say if window starts at 0 and window end ends at here, so you do have an option of going through all the elements. And the window sum will essentially be, we'll include window end into the window sum as we iterate through it. And if window end is more than or equals to k minus 1, slide the window. We don't need to slide slide the window. We don't need to slide if we have not hit the required window size of k. So if window end is more than equals to k minus 1, we append the average into the results. We remove the window start from the window sum, and we increase the window start by 1. And we repeat the process as the window end keeps iterating. So I think at this point, what would be good to do some sort of a dry run of this algorithm. So let's take the example here. So essentially what we are doing is we have a window sum, we have a window start. Let's try to keep a track of all these elements. Window start, and we have window end. So when we start, our window sum is 0, our window start is 0, and our window end is 0 as well. So at this point, what we do is we take the first element and we add it into the window sum. And if window end is more than equals to k minus 1, which isn't the case as k is 5, so we keep continuing this loop here. And again, we go ahead, and so window end at this point is 1. We increase the sum to include 3 as well. This will be 4. And window start. So again, we see if window end is more than or equals to k minus 1, which isn't the case. We keep on increasing and adding this number here, which will be 6. Window start will remain the same. Window end will increase by 1. Again, this wouldn't meet the condition. So we go ahead and add the next number as well. So this will be 12, window end will be 3, and window start will remain as it is. once again, this condition would not be met. So what happens is we subtract 1, window start will remain the same, window end will become 4, and this condition will be satisfied here. Window end is indeed 4, which is equals to this, and what it would do is we'll okay, so let's also keep a track of results. So we'll add 11 by 5 in results. From the window sum, we'll remove the window start, which is 1. This will become 10, and window start will go to 1, and window end will go to 5. So at this point, what would happen is we'll again get into the same routine. Where we increase the window sum by the 5th 0, 1, 2, 3, 4, 5. We'll add 5 here. The window start will remain the same, window end will go to 6. But at this point we see that this condition will be satisfied from here on for all the windows. So you will just keep appending the results. So you can think of this condition as allowing the initial window to stretch to a size of k. So it started with a size of 1, and we allowed it to stretch it until the size of k. And once it is stretched, we just keep moving and putting the results into the results array here. So I hope this provides an intuition around how this algorithm is working. This bit was a bit, this bit was not that clear for me initially, but right now it makes a lot more sense. So yeah, so from like, I hope this was a good sort of overview of what sliding window means and how to approach simple problems. In the next video, I'll go ahead and start with all these problems we have here, and hopefully we'll be able to address both proposing a solution, but at the same time getting the right time complexity and space complexity. I hope you enjoyed the video. Please let me know in the comments if the video was clear enough or if I can improve. Until the next video, enjoy your day, and I will see you soon.